Corrosion studies the interaction of materials with the environment in order to understand and manage the reliability and lifetime of everyday engineered artifacts, components, and structures. In order to understand corrosion, you need to learn about materials, environments, and how they interact with each other. In this section, you will learn about some of the factors that influence the corrosion process and some of the types of corrosion that occur in practice. Corrosion occurs when a metal reacts with chemicals in the environment, generally producing a corrosion product. Different metals have very different tendencies to react. For example, gold is so unreactive or noble that it is normally found in nature as a pure metal. A common commercial use of gold is to coat electrical contacts to prevent oxidation, which would otherwise increase the contact resistance. On the other hand, sodium reacts violently with water and exists in nature only as a combined chemical, for example sodium chloride or common salt. It is rarely used in a metallic state and violently reacts with water to form sodium hydroxide or caustic soda. Metals can corrode in all aqueous environments, those that contain water or water vapor. And a common consequence of corrosion is the formation of corrosion products on the metal surface. The picture shows an iron nail from the Roman era that has been buried in soil for almost 2,000 years. So, what is the corrosion product that is formed on the nail? Clay is the name given to soft silicate compounds used to make bricks and pottery. Steel is an alloy of iron, carbon, and other elements. While iron carbide is a compound of iron and carbon that forms in carbon steels, in small amounts it makes the steel strong, and in larger amounts it causes it to be brittle. So of course the corrosion product on the nail is rust, and rust is a common name for the corrosion product that forms in iron and steel. The outer layers of the corrosion product tend to have a red-brown colour and consist mainly of hydrated iron oxide. Layers closer to the metal surface often consist of magnetite and are more black in colour. Some other metals also have corrosion products that are colloquially called rust, for example white rust that forms in zinc. However, this use of the term rust is not really appropriate. Pure metals consist of a single metallic element, but unfortunately they often have poor mechanical properties. They are soft or not very strong, and they cannot be used in practical engineering applications. Unless a specific physical property is needed, such as electrical conductivity, where pure copper is a good choice, most metals are alloys. That is, they are mixtures of metallic elements, often with small amounts of non-metals, such as carbon, also present. Alloys are designed to have optimized properties, such as strength, corrosion resistance, weldability, all balanced, of course, against the cost of producing the material. So, which of the following are pure metals, which are alloys and which are neither? Brass is, of course, the alloy of copper and zinc. Carbon is an element found naturally in diamond and graphite. Copper is a metal conducting heat and electricity well. Polythene is a plastic or a polymer of ethane. Steel is an alloy of iron and carbon. And tin is a relatively noble metal used inside certain food cans. Brass therefore is an alloy, carbon is not a metal, polythene is not a metal, steel is an alloy, tin is a metal, copper is a metal, and we can check if we're correct by clicking that. You will have already seen how gold, a noble metal, is unreactive to water and so does not corrode, while sodium, a base metal, reacts violently with water. In the same way, all metals and alloys in a particular environment can be classified in terms of their reactivity to water, and this forms the basis of an electrochemical series. Looking at these materials here, Magnesium is clearly the most reactive, and gold the most noble. Silver is less noble than gold, but more noble than copper, and iron is more noble than magnesium. And if we click that link, we could check it. All the metals from copper upwards are relatively noble, while metals below copper are base and will corrode in acids and will corrode in all other environments as well. You have learnt now that noble metals gold, silver and platinum resist corrosion by virtue of their unreactivity, while base metals form corrosion products by reaction. Some metals, however, are naturally corrosion resistant because their corrosion products form in a way that protects the underlying metal. Thus, if the corrosion product is thin, adherent, insoluble, and quickly reforms, particularly after it is scratched, then the metal is said to be passive. So a passive metal is where the corrosion product is protective to the metal surface. However, not all corrosion products are protective, and the rust that generally forms in steel, for example, does not form a protective passive film, except and under alkaline conditions. So let's check which materials are passive, and this indicates that stainless steel and aluminium are both passive. If we click on carbon steel and gold, we can see what happens to them. Carbon steel is not passive, it is an active metal, and gold is immune from corrosion. So the correct answers are stainless steel and aluminium. We got them right. The main problem with corrosion, apart from the waste of scarce resources and materials, is the economic cost to people, industry and the environment. Corrosion is not really a technical problem, because in most cases it can be reduced or eliminated given enough money. The main aim of corrosion control, therefore, is to design systems and equipment to deal with corrosion in a cost-effective and environmentally sustainable manner. So, how much do you think corrosion costs each year for each person in Britain? Let's check the hint. This tells us that several studies have shown that the cost of corrosion in developed economies is in the range of 3% of gross domestic product. What exactly is that? That was around about £850 per person per year in 2008. You should now understand that corrosion is caused by the reaction of metals with the environment, and that different metals react at different rates. A few noble metals are immune from corrosion, but all other metals react to form corrosion products. Some metals, though reactive, are naturally corrosion resistant and appear to be passive, and this is due to a thin, protective corrosion product that forms over the metal surface. And finally, the economic cost of corrosion is substantial, around 3% of GDP per year for developed economies.